All right, this video is about University of North Georgia bridge building competition for 2023. Here's the idea. You will design and 3D print a bridge to span a distance of 150 millimeters, that's about 6 inches. To test the bridge's strength, we'll wrap a 40 millimeter wide strap around the bridge and hang weights from the strap. So your bridge needs to have a flat section at the top where we can put the strap. Limitations are that the bridge must be a single piece of 3D printed PLA. You may not glue, tape, or weld several pieces together. You can't use anything in your bridge other than PLA, and it has to be from one single print. So limitations are the bridge must be a single piece of 3D printed PLA. No material other than PLA or PLA Plus may be used, so no ABS, no PTEG, no other filaments. And the total mass of the bridge must be less than 75 grams. Okay, so those are your rules. And the idea here is we've got two tables that'll be separated from each other by 150 millimeters, and your bridge has to span the two tables and support the weight. So what we're going to do, like I said, is we're going to wrap a strap around this bridge, so it goes over the top of your bridge and then around and underneath, and that's going to be a circular strap. And then we will have a hook that hangs from that strap that then supports weights, and we will hang weights from the bridge until it breaks. Okay, so the bridge that holds the most weight is the winner. Pretty simple. And I mostly wanted to make this video to introduce those of you who've never done a 3D design to how you could design your bridge. I guess that's one rule I didn't mention. This should be a fully new design, not a modified file from Tinkercad or from Thingiverse or any other STL repository. So I want you to design your own bridge, not just 3D print a bridge that somebody else designed. All right, so how are you going to design your bridge? You can do any CAD software you want. The two I recommend for people who have never done CAD before are Tinkercad, Tinkercad. Sorry, I've moved away from the computer to plug in because I'm about to run out of battery. Tinkercad, if you're brand new and you want something easy, or Onshape, if you want to try something a little bit more exciting. So if you use Tinkercad, if you haven't used it before, you'll have to create an account. So I'll do sign up, and we're going to do a personal account, and we're just going to sign in with Google. So I already have a Tinkercad account because I have made many, many things in Tinkercad. But let's make a new design. And let's make a bridge. So Tinkercad allows you to bring in different shaped objects. So I think a bridge is going to look like okay, hold on. Let's rotate this thing around. There we go. Oops, 90 degrees. Okay, so it's going to look like that. And let me give this thing a size. I want this to be, let's say 100 millimeters that way. Oops. All right, hold on. Delete that. Let's bring in a new one. Okay, there's my shape. Okay, I want this to be 100 millimeters that way let's say 40 millimeters that way, and 50 millimeters tall. And then let's make another one of those. So I'm going to duplicate that and then rotate it 180 degrees. And then the idea here is to have two of those. Okay, so I'm going to select those, and I'm going to use the Align tool. And this Align tool will get them so they're straight in line with each other. Okay. All right, and then let's get a rectangle to go between those guys. And I want my rectangle to be 40 millimeters wide, and I want it to be 40 millimeters wide because that's where the strap's going to go. And 40 millimeters this way because that's how wide my bridge was, I think. Yep, 40 millimeters. And I'll go ahead and make it 50 millimeters tall. Whoops. Don't know what I just did, but we'll make this 50 millimeters tall. And then let's align all of these guys so they're in a straight line. And then I'm going to move that one over till it just touches, move that one over until it just touches, and then I'm going to take those three things and merge them. So now they're one solid shape, except I see I have a little gap in that one. So let me undo that and move that over and merge those together. So now they are one solid shape, and that's my bridge. Okay, but that bridge looks pretty heavy, so I'm going to cut some holes in it. Let's take this thing and make it 30 millimeters wide and 30 millimeters tall, and I'll make it, I don't know, 150, 300 millimeters this way. And then I'm going to use this little arrow and drag it up 10 millimeters. So now that hole is sitting in the middle of my bridge, and select the hole and the bridge, merge them together, and now my bridge has a hole in it. Make it a little bit lighter. Let's see. We can actually make any shape we want be a hole. So I'm going to take this triangle and rotate it 90 degrees, and let's make it 30 tall and 40 wide, sure. And again, let's raise this up to 10 millimeters above the ground. And now I can put, okay. And I'll also make this thing like 60 millimeters wide. And then I'll just put it into my bridge here. And what I'm going to do is turn that into a hole, because any shape I make can be a hole. And now I'm going to copy that, make another one. And I'm using the arrow keys to move this thing directly horizontally. So I can make another hole there. And let's see, I guess I'll put one hole there, and let me make another one of these and rotate it 180 degrees. And I'll put that one up a little higher, put that one there, and now select this whole thing, and now I've got a bridge with some holes in it. And maybe that's good enough. So I'll select this object and I'll export it as an STL. And let me go ahead and call this bridge 1. Okay, so that's a very, very basic thing on how you might build a bridge using Tinkercad. There are lots of online tutorials for Tinkercad, and of course this isn't a very good bridge the way it is, but you could do that. All right, the next option would be to use Onshape. If you're going to use Onshape, you should create a student account. If you create a student account, you'll have to put in all your information and create a student account. I've already done that, so I'm going to sign in. Hope this is right. Oh dear. All right. There we go. All right. And again, I have designed lots and lots of different shapes in Onshape, but let's create a new document. Let's call this Bridge 2. And Onshape's a lot more complicated to use, and I recommend using tutorials online to do Onshape. But right now, I'm going to go ahead and select my top plane and create a sketch. And I'll hit N to look straight down on that top plane, and then I'm just going to start. Actually, hold on. I don't want to sketch on the top plane. I don't think. I think I want a sketch on the front plane. So sketch and to normal. Okay. So I'm going to draw a bridge. Okay. And now this will let me put in some sizes. This is my dimensioning tool. So I want my bridge to be 250 millimeters long. I want this top piece to maybe be 100 millimeters. I would like this angle to be 45 degrees. I'd like this angle to be 45 degrees. And let's make this thing, well, actually I don't want to dimension it that way. Let me dimension it this way so I can be, let's go 60 millimeters tall. Oops, didn't like that. Okay, delete that dimension. So what am I allowed to do? Why is that still blue? Usually blue line, can I make that 100? No, I can't. Usually blue line means it's not fully dimensioned yet, and oh, I know, because I'm not, I think I can move this whole thing left and right. So let me make let me make a midpoint. Midpoint. There we go. All right, now it's fully dimensioned. Okay, so, but, you know, not really done. I want to make some let's make that horizontal. Okay, and let's make this, oops, I'll dimension this to be 45 millimeters tall. That's 45 millimeters and something it didn't like. Okay, well, let's see. Let's make this and this vertical. Okay. And then let's dimension this so that it's 10 millimeters above the base. And that's fully designed. All right, and you know, I could do the same thing. Yeah, let's go ahead and do the same thing over here. All right, so I'll make that horizontal. That's already vertical. I'll make this 45 tall, and I will select these 2 points and say that they are vertical, and then I will dimension this so that it's 10 millimeters above the ground. That's vertical. That's horizontal. That's 45. Oh, I guess I have to make this 45 now too. Okay, so that fully constrains it. Okay, so now let's make our bridge. So that's our drawing. And then to make the bridge, what we need to do is extrude this. So I'm going to select this thing, and we're going to extrude it 40 millimeters. And that is going to make our bridge. So there's my bridge. Again, not a very good bridge, but that's okay. So I'll select part 1 and right click and export as an STL. So we're going to call this bridge 2 and export it. All right, so now we've created 2 bridges. So the next stage would be to go to Cura. Oh, so you're going to need to download Cura. So that's Ultimaker.com software, Ultimaker Cura, or you can just Google search for Cura, C-U-R-A, and download the software here. I've already done that. So let me run Cura. By the way, all this software works fine on Mac or Windows, so no need to worry about that. All right, get started. I agree. Next, I'm going to skip creating a login, and I'm going to add a non-networked printer, and it should have the printer we need. We have Creality, and ours are Ender 3. It's not really an Ender 3 Pro, but that is close enough. We've got Ender 3 version 2s and Ender 3 S1s, but Ender 3 Pro is good enough for Cura to use it. So all these things are fine for the settings. Actually, we're going to make some changes to the start code, but don't worry about that for now. All right, whatever. Okay, skip all this. All right, finish. Okay, so here is Cura. It's set for an Ender 3 Pro. It's set for generic PLA with a 0.4 millimeter nozzle. All that is correct. We want generic PLA, 0.4 millimeter nozzle, Ender 3 Pro. And then we can open the file that we want, and I'm going to go to Okay, we're going to go to my downloads, and we'll bring in the bridge I made in Tinkercad. And you see it's actually too big to fit. Can I make it fit if I put it on here diagonally? All right, so that is another limitation of our design, is it's got to fit on an Ender printer. So it has got to fit within a 200 millimeter by 200 or 220 millimeter by 220 millimeter surface. So this is actually going to fit once I change some settings. Custom. All right, so build plate adhesion, none. That'll work fine if you have a nice flat part that can stick to the bed easily. So now my part fits onto the build plate. So this is a now buildable part. See how it's showing me red there? Those red parts are parts of my print that are not supported. So it's like trying to print something in midair. That could fail if I try to print that, but that's okay. I'm going to try to print it anyway. It might not work, but I'm going to try it. All right, so we got several settings that are important for you guys to look at. The first one is quality, and we can keep that at 0.2 millimeters. That's the layer height. So each layer is going to be 0.2 millimeters. That means that's got to print 5 layers for each millimeter of height. Walls, this you might want to change. Increasing the wall count is going to make your print heavier, but it's also going to make it stronger. 2 is standard, but for a bridge, I might go as high as 4 or 5. It's up to you, but that's a setting you can change to adjust the strength of your prints. The next thing is going to be infill. Infill, well, how much plastic gets printed on the inside of the object. So I'll leave this at 20 for now, and those are the 2 main things that you might want to change. The other thing you might want to change is whether or not you want to print supports. And right now I'm not going to, but I'll show you both versions. So once we've got all the settings the way we want it, we click Slice, and Cura is going to tell us how much plastic it's going to use to make this, 68 grams. Now that fits within our rules. I think our rules said it needs to be less than 75 grams. So 68 grams is legal, so that would be allowed. But now I want to preview this and show you what it looks like. So this shows how the print is going to go. So it's going to print that first layer. It's going to keep, and then this is the infill. This is our 20% infill. So you can see inside the solid parts of the bridge, it's not filled with plastic. It's only 20% filled with plastic. Okay, and then we get the solid part of that, and you can see on these vertical parts, again, it's not fully filled. So we're making the triangles, and then this is the part that's going to have trouble printing, right? Because right there, when it tries to print this layer, it's going to be printing on top of open space, and that's doesn't always work for 3D printers. So okay, and again, now that is going to be really hard to print. Because again, you got a big hunk of plastic that's just hanging out in open space, and when the nozzle pushes out the plastic, it's potentially just going to fall all the way down to the ground instead of actually printing there. Okay, and so we go up and finish the top of the bridge. Okay, so actually I don't think that's going to work, so let me go back to my settings and change some things. So first of all, let's go ahead and print supports. And I'm going to do this. Yeah, that's fine. We'll leave those standard settings. So now I'm adding supports. The other thing I'm going to do is increase my infill, this time to like 60%. I just want to show you what that's going to look like. So we slice that, and first thing I notice is it's 141 grams, which is way over our 75 gram limit. But this includes the supports, which we're going to remove before we actually weigh the bridge. So it might be okay, but probably not. So let's preview this. Okay, and what I want you to see is this blue part is the supports. So it has printed in this blue section of the print, and that blue section of the print is something that we will then remove from the bridge before we actually test it. But it will make it so that when it tries to print here, it will have something to print on. And when it tries to print here, it will have something to print on. And it tries to print this in a way that it's easy to separate out the support from the bridge itself. But in my experience, no matter how well the program tries to make that support material easy to remove, it never is easy to remove. And you can see that support material is like fully encased inside this bridge, and it would be very hard to get it out once the bridge is printed. So you might want to design your bridge in a way that you don't need supports, or at least you need fewer supports. Okay, this tells me that it'll take 14 hours and 45 minutes to print, and it'll use 141 grams of plastic. And yeah, so that's useful information in knowing whether or not this bridge is going to be good for the competition. Okay, so basic outline, we've got our rules, got the basic idea, 2 tables, a bridge, hanging weights. You can use either Tinkercad or Onshape or any program you want to design your bridge, and then ultimately, once you've got your bridge designed, you can use Cura to figure out about how heavy it's going to be once it's printed. The way we're going to do the competition is you'll send the STL files to us, and we will print the bridge for you using our PLA, so everyone uses the same material for the final competition. So you'll just send us an STL, and you can tell us, what infill do you want. Oh, that's the other thing I wanted you guys to see here is the stuff that's printed inside the solid part. I don't know if you remember the old one. There were a lot of big open spaces, but with 60% infill, that inside is mostly filled with plastic. So a 60% infill part is going to be a lot stronger than a 20% infill part, but it's also going to be a lot heavier. So you're going to have to decide how to optimize that. Okay, I think that's all.